This morning on Practical InfoSec, I thought I'd talk about putting security into the IT solution lifecycle. I spend many times on loan to our strategy and technology group during our idle initiatives in our data centers, doing a lot of security assessments. And one of the things that we found was very important is the earlier you can put your security into your lifecycle, the better you're off you are in terms of managing that infrastructure, and it becomes more secure. There are actually three elements where you see improvements. It saves you time because you don't have to go back and fix things later. It saves you cost because rather than having to go out and patch things and get additional technology, it's all cooked into the solution from the beginning, and you know what risks you have for a particular infrastructure going forward, and it lowers your risk because, again, you examine what you're trying to do in a piece of business automation or business solution in terms of security, and you map that back to how that aligns with your policies and controls. So talking quickly about a standard system lifecycle, and we all have slightly different variations of the theme, but in general, the phases are concept, that's where you do the solution rationalization, the business case, requirements gathering, and I can't stress enough, as they gather business requirements and technical requirements, you ought to be gathering security requirements too. That's important. If you understand your security requirements going into a project, the more success you'll have in securing that solution at the other end. And then after you get all that done, you go into the typical design, and that's the detailed design, picking out, all the technologies you're using, and actually starting to take a broad brush, and it's a lot of cases iterative. You pull that stuff together into a solid design, or in some cases, some organizations just go back to the closet, see what they've got laying around, and throw it together. Obviously, the more planning and the better design you have going in, the better security you're going to have coming out. After that, you've got your build phase, and that's basically taking the design documents and going and building it. Sometimes you'll have a proof of concept cycle where you build up and mock up a proof of concept, but often that's done actually pre-design or part of the design. Test, another important stage. That's where all the testing comes in, performance and regression testing, user acceptance testing, testing of build against design requirements, etc. The following phase is typically implementation, and this is another key area where you actually temporarily, depending upon how you do implementations, you can temporarily open yourselves up to great risk, because some of the tools that you do in implementation may be worse off than either the system you're replacing or the system you're going to. So be mindful of that as you have people trying to do implementations. Are you protecting the data during the implementation? If you're transferring data from an old legacy system to a new system, the new system might be more secure, and the legacy system maybe not be up to standards, but it's what you've had. But the method that you use to move that information needs to be at least as secure as the old system. And then you go into production, which is the steady state operational things that we care and feed for every day. And as things move through their operational steady state, that's where you see your typical security, vulnerability assessments, pen tests, etc. And you need to keep that up as well. And then finally, at the end of its life, it's going to be retired and decommissioned. So during those different phases, we found that a gating process and a review process was required for security. And we actually built different security assessments for each phase of those concept to production life cycles or system life cycles. So make sure that you do some, even just a security meeting or a security discussion if you're in an informal organization. If you're formal, obviously you need to make it more robust. So the results of these assessments, they don't have to necessarily be long, and they tend to build on each other. So, if you do a really good design assessment, that really sets you up to take you through build, test, and implementation. So through all these gates, you should do a no-go, no-go check against what you found in your assessments, and make sure that as part of your assessments, you come up with remediation and recommendations on how to fix problems you find. Don't come in and say, this is never going to work, abandon all hope. You have to actually, it would behoove you to be more proactive and say, rather than curse the darkness, I'm going to light a candle and say, this is what you got wrong or what we got wrong, and this is how we're going to remediate and fix it. Or, here's halfway to the preferred solution, then we have to accept the rest of the risks. But at least you're going through the process with open eyes, and the business understands what risks they are accepting to live with. So I'm going to talk about basically the three kind of gated assessments as I see importance for this concept to production model. And the three gates that I feel are very important: design, build, and implement. I mean, people spend a lot of time talking about test, and while test is very important, I think that there's more focus on that phase. So the other three phases ought to get a little bit more attention than they are, because a lot of times design isn't even a consideration. A lot of times in security, you find out about it after the guys implemented it, and you're running around with pen test tools trying to figure out what they did, how they did it, and whether it's any good. So putting a design security assessment in place is pretty useful. And the objectives of that are, does the design achieve the level of security that's required by the business requirements and the technical requirements? If the solution is deployed as designed, will the solution be, risk averse in terms of security? So you want to make sure that your organization realizes its return on investment. And so if you have a lot of additional risks that cost you money, you're not getting that return on investment. So some of the design assessment tasks that I like to see, you basically go in, and a lot of it's back to the NSA information assessment methodology. You go in, you identify your information assets, and you rate them in terms of confidentiality, integrity, and availability. Identify any regulatory issues with those information assets. Then you go back and identify what kind of logical services are used. And by that I mean, what are the data formats of the data? What kind of databases, what kind of protocols, what are the applications and services, if it's using RPC or some of these, what IP protocols are you using, or is it UDP? And again, you're going to have control standards with your policies that govern how those are used, or you should. And by doing this exercise, that'll allow you to figure out ahead of time what your controls need to be. Map your information assets across the network traffic flow. What does the data look like at rest, and what does it look like in motion? Make sure you understand all those information flows, because that way you can protect it according to the value of the data. Map your business requirements to the applicable security policies and controls. Typically, with most of these design documents, there are a set of business requirements. They will map to codes of conduct and how you behave in an information security manner. So make sure you map those requirements. And then from all that information, you're going to look at things, and you're going to be able to determine, where does a design meet your standards and where does it fall short? And if it falls short, that's how you can go back and say, okay, well, you know what? You were using a fat client on this type of architecture, and we don't do that anymore. Or, this is not a best practice. You need to rethink about some of these things. Again, with privacy data, if it's encrypted in the database, at the database host, but yet the client is opening a browser and it's clear text in the browser cache, that's where you want to fix that. So moving on to build, after you get all the design kinks worked out, you got to go off and build it. And again, the build goals follow directly onto the design goals. Does the solution as built achieve the level of security that is required? And if it's deployed as built, will the solution result in greater security-related risk, and will it affect your return on investment? Can you mitigate those risks without endangering your investment? And again, the build assessment, you take the design assessment, you move it into your build assessment, and based on your information assessment and your information assets, you validate that, what you advertised in design is what you got in build. You revalidate your regulatory issues, if there are any, and then you validate your logical services used, make sure that, the stuff that was in the design documents turns out is the stuff that you're using. If they changed middleware, if they changed the database, you need to account for that. Likewise, when you go through, you're going to look at the design assessment and your relevant security policy standards, and then go back and review the configuration on your hardware and your software. We all have password policies and other hardening policies. So if you have a hardening policy for a platform, this is where you would apply that to this particular design as it's built on that hardware. And again, like the other design assessment, you follow the information down through the assessment machinery, and you come out with your findings, and then you document your recommendations. The implementation is similar. It follows on, but there's a little bit of a different catch here. Does the implementation maintain the level of security required by the requirements? Is this a greenfield solution? Meaning, is this going in and it's a brand new thing where nothing existed before? That might be a little easier because you're standing up something from nothing. However, if you're taking data or information or replacing a legacy system, at that point, you need to look at how are you migrating that information from the old system, and how are you retiring the old system, and in some cases certifying the destruction of the media and moving it into the new system. What is the fallback? There are a lot of implementations go bad by being too optimistic, and you have kind of a fallback plan, but it's not a very robust one. A lot of it involves scurrying back to the last backup tape and restoring your old system, which is not a great way to do it, but sometimes that's the only way to do it. But make sure you're mindful of that. You want to be aware of what happens if you stand this thing up in production and suddenly, for whatever reason it was working in the lab, is now not working in your production environment. And you may need to take it back offline in production to figure out what's wrong with it before you can actually try to stand it up again. And having a good fallback plan will save you a lot of anguish, especially with your leadership. So some of the implementation assessment tasks are going to be, again, identifying those legacy data assets, making sure that you've got their level of criticality identified, mapping them to what you have determined in your design and your build assessments on the new system. And you might want to map the data. Does the data go one-to-one, or is it slightly different formats? And what happens if there's a difference in format? Does it affect your security? Identify your information migration methods and identify the logical services and the tools you're going to use for that migration, and make sure that they are at least at the level of the legacy system. They probably ought to be higher, but they certainly shouldn't be lower. But sometimes a lot of people cheat, and they can't get things working right, and all of a sudden they're moving their HIPAA data over an FTP tunnel on a weekend because they figure nobody's watching. Don't do that. Again, map your network traffic flow with your implementation. Understand how that's going to be different than your normal operations traffic. Map the transition requirements to your applicable security policies. Are there policies governing using some of these tools? And again, make your recommendations. I've given Joe several links to security and LifeCycle, and they'll be up on the chat window. And that's Practical InfoSec. Thank you.